Okay, we're going to talk about, in this new section, how to approximate an alternating series. Let S equal the summation of the -1 to the n, a sub n. Let's say n goes from 1 to infinity. S sub n is the sum of the first n terms. That is, it's the sum as n goes from 1 to capital N, the n's term. Yeah, the first, the second, the third, the fourth, and you get S sub n. That is, big X is just, well, n is 1, so it starts negative. It's negative a1 plus a2 minus a3 plus a4, etc. Here we start with negative a1 plus a2 minus a3, and so on, up to, I don't know if it's plus or minus, up to a sub capital N. Now, what I know is that S minus S sub n. I know that the absolute value of this is less than or equal to a sub n plus 1. I know that. That I know. Okay, so if I approximate my sum with the first n, by just adding up the first n terms, okay, the difference between the actual sum and the sum of the first n terms, ignoring signs, that is that, the absolute value of that difference will be smaller than whatever the n plus first term is. It will always be smaller than that. Okay, if you take the actual sum, I can guarantee you, you don't even need the actual sum, I can guarantee you the difference between the real actual sum, which you may not even know, and the sum of the first n terms. That is, you add up the first n terms, suppose S sub n is 108, and suppose that a sub n plus 1 is 0.0001. I can guarantee you that the difference between the real sum and just the sum of the first n terms will be less than 0.0001. Okay, and you don't have to know the real sum. You just know that it differs from S sub n, the sum of the first 50 terms maybe. Okay, let's suppose we do that. We add up the first 50 terms, and we'll get 108. And we calculate a sub 51, and it happens to be this. I can guarantee you that the real sum will be no more than 108, plus or minus that number. That will be the real sum. Okay? Here is 108. And the distance, absolute value means distance. The distance between the real sum and 108 is smaller than 0.0001. That is, I can guarantee you that the real actual sum is between 107.9999 and 108.0001. I can guarantee you that. And if that's acceptable, maybe you're building a bridge and you need to have something exactly 108 inches long, and somehow it comes from an alternating series, well, you can just, and it's okay to be off by that amount. Well then, just go out to the 50th term. Just add up the first 50 terms. Or maybe I meant to say something different. You know the length of something happens to be defined this way. Do you know that something actually measures that amount? And you're like, oh my, it better be 108. Oh, you don't have to actually add up, or it has to be close to 108. It has to be within that amount. You don't have to add up all the terms. You just have to add up the first 50 terms. Okay. Having said that, let's see what's up. S sub n is the sum of the first n terms, and big S is the sum of all the terms to infinity. Take you forever to add them up. You don't want to take forever. It's okay if you're within 100,000 maybe. It's okay if you're within 10. So again, we know that S, the real sum minus the sum of the first n terms, the absolute value of that is less than a sub n plus 1. Yeah, less than or equal to. So now, suppose that you want to approximate this sum by its first, of this sequence by its first 6 terms. The summation, say, as n goes from 1 to infinity, of negative 1 to the n plus 1, of 1 over n factorial. You want to approximate the sum by the first 6 terms. Okay, approximate this by, or approximate using the first 6 terms. And then find out how exact that is. Well, the first 6 terms. N starts off with 1. 1 plus 1 is 2. Negative 1 to the 2 is 1. Positive 1. That is, it starts positive. And then you get 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial minus 1 over 6 factorial. Okay, and if you work this out, 1 over 1 minus 1 over 2 plus 1 over 3 factorial is 6, 4 factorial is 24, 5 factorial is, I guess, 120, 6 factorial is 720. And I actually worked this out, and it's approximately the 5 decimal places I get, 63194. 63194. Okay, that's just the sum of the first 6. We didn't put a dent into adding up all of them. This goes out to infinity. Question is, how off are we? We know that S minus S6, which is S minus approximately 0.63194. That is the difference between the actual sum and partial sum, the sum of the first 6. This is less than or equal to, my last term was a sub 6, so it's less than a sub 7. A sub 7 is 1 over 7 factorial, which is 4900, 5040. It's less than that. Okay, that is the distance, the difference between my approximate sum and the real sum is rather small. 1 over 5040, that's going to be approximately 1 over 5,000, 2 over 10,000, tens, hundreds, thousands. It's within 0.0002. That is the real sum The real sum is in between. This is the symbol for in between. It's in between my approximation plus 0.0002 and my approximation 63194 minus 0.0002. It's a good approximation. And we know it's a good approximation. It isn't we just add up the first 6 terms and we say, oh, that's it. I'm okay. Good enough. Just doing the first 6 is enough. It's a good approximation. This is close to 1 over 5,000, which is the same as 2 over 10,000. And that's why I wrote 0.0002. It's close, it's within 2 10,000s, approximately. It's a pretty good approximation. You just don't add up the first 6 terms and go, boy, that's it, I'm not going to do any more. I hope this is a good answer, a good approximation. Don't worry, it's good. Just look at the next term. You stop after the 6th term, you're within the exact answer. How much are you within of the exact answer? The next term, the 7th term. You're within the correct answer by the next term, the 7th term. Now, let's just play the game differently. Suppose I tell you how much the most you can be off by. I want you to approximate the sum within 0.001. Okay? Approximate the sum that is error within 0.001. Let me just say it differently. Approximate the sum within 0.001 or 0.001. That is, the error is less than 0.001. Don't have an error. See, the difference between the exact amount and what you're approximating, that's the error. If the exact amount is 3 and you claim it's 2.5, your error is 0.5, it's a half. And you know, if you're off by a half, you never say you're off by a negative a half. That's why we put the absolute value. If their exact amount was 3 and you with 2.5, excuse me, and you approximated with 3, I don't want to hear that your error is negative. Your error is you were off by a half. How much are you off by? I was off by negative a half. No, you were off by a half. Okay. So I'm asking you to approximate the following series, approximate the sum of the following series within 0.001, within 1,000ths. Now, we know that S minus or Sn minus S is less than, now this is the error. This is the error. Is less than A sub the next one. You add up the first 50 terms, the error will be less than the 51st term. Okay, and here's the problem. Suppose, well, let's do this one. Same problem we just did. Summation, n goes from 0 to infinity of -1 to the n over n factorial. That is, this is the summation as n goes from 0 to infinity of -1 to the n times 1 over n factorial. That's the a sub n. And I want it to be less than 0.001. I want 1 over n factorial to be less than or equal to 0.001. Tens, hundreds, thousands. 1,000. That means, since the numerators are both the same, they're both 1, I want this to be more than 1,000. Well, 5 factorial is 5 times 4 times 3 times 2. 20 times 6 is 120. You want to say times 1, go for it. It won't change the answer. 6 factorial will just be 6 times that. That's 720. 7 factorial, well, I have to multiply this number by 7. More than 700 times, you just have to multiply this by 2 to break 1,000. We're multiplying it by 7. So, all I care is that, yep, that's bigger than 1,000. Okay, now that could be, so what I'm getting at is that this here is the remainder term. I want the remainder, I want the error to be less than 0.001. And that happens when I use 1 over 7 factorial, which is a sub 7. If this is a sub 7, that means capital N is 6. Just add up the first 6 terms. The sum of the first 6 terms, when you take away the actual sum, you'll be less than a sub 7, which is less than that number. Okay, so I won't do this, but you need to add up the first 6 terms. Possibly this is the one we just did. It's 1 over. Now we have to be careful about what I'm saying. We have to be careful about what I'm saying because they're playing a silly game by starting at 0. Remember, you have 1 over 0 factorial, and then 1 over 1 factorial, 1 over 2 factorial, and then eventually 1 over 6 factorial, and 1 over 7 factorial. That's the first term. That's the second term. Well, that's the third term in the sequence. Notice that the factorial is always 1 less than, or notice that the term number is always 1 bigger than the factorial. 6 factorial, that must have come from the 7th term. 1 over 7 factorial came from the 8th term. So we need to go up to a sub 7 actually. You have to be careful in that one. You need to go up to a sub 7. You need to go up to a sub 7. That is, so you have to add up these values. You have to add up, excuse me. No, you have to add up these values. You have to add up those values, not including the 1 over 7 factorial. 1 over 0 factorial plus minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial plus 1 over 6 factorial. And you'll be within 0.001 of their actual sum. Okay, review this tape 3, 4, 5, 12 times until you understand what I'm saying. I'm giving it to you. It's here. Let us try one more. Suppose you have the summation of -1 to the n plus 1. divided by n times 4 to the n, divided by n times 4 to the n. The problem is exactly the same. Find the sum within 0.001. 0.001, which is 10 hundred thousandths, 1 thousandth. Find the exact sum within 1 thousandths. Well, we know that this is negative 1 to the n plus 1 times 1 over n to the 4 times 4 to the n. And this problem is going to start with n equal 1. You can't start with 0 because 0 times 4 to the 0. 0 times 1 is 0, and you can't divide by 0. So I just need, so n goes from 1. I need to find out what term is less than 0.001. 1 over n times 4 to the n. Pick a value for n, maybe 4. So you get 1 over 4 times 4 to the 4. Well, 4 to the 4 is 16 times 16, 256. Times another 4 is 1024. So 1 over 1024. Now that was just a good guess on my part, because that number is smaller than 1 over 1,000. Now since you don't want to add too many terms, you might want to try what happens when n is the number 3. You might want to try that. And I'm fairly confident it won't work. We have 1 over 3 times 4 cubed. 4 times 4 is 16 times 4 is 64. Then you multiply that by a measly 3. If I'm not mistaken, you get 192. Okay, this is not less than 1 over 1,000. It's bigger than 1 over 1,000. So 4 was the first time it worked. Work means you got a term that was smaller than the error you wanted. N is 4. Well, just add up until n is 3. Notice I didn't say add up the first 3 terms, because you might start with 0. It may have said start with 0. Add up until n equals 3. So what we want to do is add up. Since n starts at 1, we start at 1. So we go up to 3. Negative 1 to the n plus 1 over n times 4 to the n. First n is 1. So that would be 2. Negative 1 to the 2 is positive 1. So that 1 over 4 to the 1 is 4. 1 times 4 is 4. Minus. Now n is 2. 4 squared is 16 times 2 is 32. Plus now n is 3. 4 cubed is 64 times 3 is 192. Can you add up these numbers? That is, you get a common denominator, which in this case will be 192. 4 goes into 192. Well, 50 times, it goes in 48 times. So I multiply the top and the bottom by 48. So I get 48. 1 times 48 is 48. And get 48 over 192. Multiply top and bottom by 6. 1 times 6 is 6. So I get minus 6 over 192 plus 1 over 192. 48 minus 2 is minus 6 is 42 plus 1 is 43. 43 over 192. That's my approximation for the answer. And it is for the sum, for the entire sum. This entire sum is approximately 43 over 192. Well, somebody says approximately. I mean, how good of an approximation is it? Oh, it is within 0.001. That sum is within 0.001. The difference between the actual sum and my approximation of the first first 3 terms is within 1,000. And if the reason, if that's okay, if that's an acceptable error, well then fine. You could approximate it that way. Calculators use this all the time. When you want to find the sine of an angle, the sine of x can be represented by an infinite series. And since your calculator only gives up until 8 decimal places, say, for example, they only have to count maybe the first 12 terms in that series to be within 8 decimal places. And trust me, they don't go to 10 places, they don't calculate it to 15 places and only give you the first 8. They don't do that. They only go up to 8 decimal places. There's no reason to calculate it out to 15 places but only give a display that has 8. Okay, that finishes the section on calculating the error of alternating series. Next we'll go into conditional series, conditional convergence.